The first term you're going to hear a lot is convex polygon, and we're going to pretty much be talking about convex polygons all throughout the unit. And those are just polygons where all of the vertices point outwards. So for example, if you have what you guys usually see as a pentagon, whoop, that's not very convex, but all of the vertices are pointing out, kind of like arrows, or they all look like angles, just like we're used to. A concave polygon, which we're not really going to deal with this unit, is one where the vertices point inwards. So let's say this was my polygon. This is concave because the vertex is pointing inside the polygon, and we're not really going to use them very much in this unit. We're pretty much going to always talk about convex polygon, and it's not going to be something you're going to have to straight out define, but you are going to have to be able to get past the word convex and just understand that it's a regular polygon that you're used to. Okay, the next vocabulary is what's called a regular polygon, and this is going to be a polygon that has all of its sides and all of its angles congruent to each other. So a very popular regular polygon would be a square, and that's where all of the sides are congruent and all of the angles are congruent. Okay, we're also going to learn about a rhombus this unit, and a rhombus, remember, a rhombus has all of its sides that are congruent, but in a rhombus you have some acute angles and some obtuse angles, so that's not regular. Regular means all sides are congruent and all the angles are congruent. And the last vocabulary word that you're going to hear a lot this unit is what's called a diagonal. And remember when we were talking about with special right triangles, I always gave you that problem where you had a square and it's diagonal, and you guys all knew how to draw the diagonal. The diagonal was this thing in the middle. This thing in the middle can be in any polygon. It doesn't have to be a square. It could be a polygon like this. The diagonal is any segment that can be drawn from one vertex to what's called a non-consecutive vertex, meaning this vertex to this vertex would be consecutive because they're right next to each other. A diagonal connects two non-consecutive vertices, vertices that are not right next to each other. They're kind of across from each other. So we can connect a diagonal to these non-consecutive vertices, these non-consecutive vertices, these non-consecutive vertices. That's a diagonal. Okay, when you did your little warm-up this morning, we actually used diagonals, and the diagonals helped us to figure out what's called the polygon interior angle sum theorem. The interior angles of a polygon are the angles that exist inside the polygon. And when we measure the angles, you guys know in a triangle we always had 180 degrees. And with the diagonals, we said, okay, well, let's connect diagonals in a polygon and make a whole bunch of triangles with those diagonals. And we knew that each of those diagonals created a triangle, and each of those triangles had 180 degrees. And then from that we derived the formula for any polygon and its interior angles. And we said that you take the number of sides of the polygon, which is represented by n, you subtract 2, and you multiply whatever that is. So you have 10 sides minus 2, 8. You multiply that by 180 because there's 180 degrees in each triangle. So this is the formula for the sum of the interior angles of any polygon, where n is the number of sides that the polygon has. So, for example, the triangle here. We know just because of pure knowledge that a, b plus c is 180 degrees. But if we use the formula, we'll also get 180 degrees. Using the formula, we take the number of sides, 1, 2, 3. We subtract 2, which hopefully you don't need a calculator to do 3 minus 2, it's 1. And then we multiply that number times 180. So there's 180 degrees in this triangle. We do the same thing with any polygon. We take the number of sides, 1, 2, 3, 4, 5. We subtract 2, which hopefully you don't need a calculator again. That's 3. and we multiply that number times 180. So 3 times 180 is going to give me 540 degrees. Okay, now we're going to have to apply that theorem algebraically. It's just like a triangle. When you had the interior angles labeled in a triangle, we always took the 3 angles, we added them together, and we set them equal to 180 degrees. Well, now we just have to add a step to that. We have to figure out how many degrees is inside the polygon and then set all that algebra equal to that. So the easiest way for me is just to divide the polygon into triangles. So I would just connect this vertex to this vertex, and all I can make out of this polygon is 2 triangles, and each triangle has 180 degrees. So 180 plus 180 is 360. That's how many degrees makes up this polygon. The other way you could do it is use the formula n minus 2 times 180, where there's 1, 2, 3, 4 sides, subtract 2, multiply by 180. 4 minus 2 is 2 times 180, that's 360. So either way you do it, there's 360 degrees inside this quadrilateral. So if I add 3x to 90 to 90 to x, if I add all those angles together, their sum is 360 degrees. And then you just solve for x. 3x plus x is 4x. 90 plus 90 is 180. And all that equals 360. Subtract 180 from 360, and you get 180. That equals 4x. You're going to take 180, divide by 4. So you get x is 45. Okay, so I'd like for you to pause the video and try number 2 on your own. Your first step is to figure out how many degrees makes up the interior angles of this polygon. You can use this formula here or divide the polygon into triangles. Then you're going to set up the sum of all those interior angles equal to whatever you get in this formula. Pause the video and see if you get what I get for the value of x. Okay, and you should have gotten x is 37. If you didn't get that and you're not sure how to get it, raise your hand. Okay, the next example using the interior angles formula, it's asking for the measure of one interior angle of a regular convex octagon. Remember, convex is just a fancy word for the polygons that we usually deal with. Okay, so we want a convex octagon. We want to figure out what all of the interior angles of a convex octagon is. Well, an octagon has 8 sides. You subtract 2, multiply that by 180, so you get 6 times 180, which is 1080. This 1080 represents the sum of all the interior angles of a regular octagon, or of any octagon. So here, let's just say that this octagon is regular. That means that this angle, 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 they equal 1080 degrees. Now, how do I find one of those interior angles? Well, if it's regular, that means all of the sides are congruent, which also means that all of its angles are congruent. So I have 1080 degrees to split evenly amongst 8 angles. So I take that 1080 and I divide it by 8. So that gives me each angle is 135. And check it. 135 8 times should equal 1080. Alright, I'd like you to pause the video and see if you get what I get for the interior angle, just one of them, of a regular convex nonagon. And you should have gotten 140 degrees. Okay, now let's talk about the exterior angles of a polygon. The exterior angles of a polygon, this one's cool. The exterior angles of any convex polygon is 360 degrees. Well, there is no formula, it just is what it is. You measure all the exterior angles, you get 360 degrees. So this exterior angle plus this exterior angle plus this exterior angle is 360 degrees. and you have a 1, 2, 3, 4. You have a quadrilateral here. The exterior angle 105 plus 40 plus 105 plus 110 is 360 degrees. Now, the really important thing about the exterior angles is if you notice the exterior angle here and the interior angle here form a linear pair. Therefore, they're going to be supplementary, and this is going to help us out a lot. So here, if this is 140, then this angle inside is 40. If this is 120, then this angle inside is 60. And if this is 100, then this angle inside is 80. Now look what just happened here. By knowing the exterior angles, I was able to figure out the interior angles. Ooh, I'm excited. All right, so here, I know the interior or the exterior angle is 40. So the interior angle here would be 140. Exterior angle is 105. The interior angle is going to be 75. And look what's happening here. I can figure out the interior angles by knowing the exterior. All right, now this first problem. We notice these are all exterior angles. And we know all of the exterior angles of any polygon is 360 degrees. So we're going to add all of our like terms. 3x and 2x is 5x. Plus 5x is 10x, plus 2x is 12x, plus 6x is 18x. I have a positive 10, a negative 5, so that's 5, and another negative 5, so that's 0, equals 360 degrees. So all I have to do here is take my 360 degrees and divide it by 18. So I'm going to get x is 20. Okay, so what if we want to find out one of the exterior angles of a polygon if the polygon is regular? Well, remember, if the polygon's regular, all of the sides are congruent, all of the interior angles are congruent, and that's going to make all of the exterior angles congruent. So, if we want to know what one of the exterior angles of a polygon is, we take what we know about all of the exterior angles. All of the exterior angles have a sum of 360. Divide that by the number of exterior angles that there are. 1, 2, 3, 4, 5, 6. So if all of the exterior angles of this hexagon are 360, and you have 6 exterior angles to divide that evenly amongst, you take 360 and divide it by 6. So the exterior angle, one exterior angle of this polygon, is 60 degrees. Okay, so now I want you to do it without a picture. What is the measure of each exterior angle of a regular nonagon and a regular septagon? Septagon is like the number 7, so it's a 7agon. Pause the video and make sure you get what I get. Okay, so you should have gotten 40 degrees for the nonagon, that's one of the exterior angles, and 51.4 degrees, that's a rounded value of a regular septagon. Okay, now what if we have one of the measures of the exterior angle of a regular polygon? What if it's 30 degrees? To figure out how many sides the polygon has, we're going to do the same thing we just did in the problem above. We're going to take the 360 degrees that we know all of the angles equal, the exterior angles equal, and then divide that by just one of the exterior angles to see how many sides this polygon has. So 360 divided by 30 gives me the number of sides, which is 12 sides. Furthermore, if we know one of the interior angles of a regular polygon, so remember, interior angle, let's just say this is 170 of a regular polygon. To figure out how many sides this has, we have to get to the exterior angle. So remember, the exterior angle is supplementary to the interior. So the exterior angle is 10 degrees. So the exterior angle is 10 degrees. We take how many degrees there are total, 360, and divide it by 10 degrees. So that means that 10 degrees is split evenly amongst 36 sides.